Alright, maybe I'm not that cringe. This is TNE10005 Network Administration Lecture 3. Today we're going to talk about second part of project management and also introduction to TCP, IP and IP subnetting. Alright, so without slowing down more things, so let's get into it. Alright, the first thing we're going to show you is the 10 areas of PMBOK. Last week we learned about integration management, scope management, time management, cost management, and this week we're going to learn from area 5 onward, which is quality management, human resource management, communication management, risk management, procurement management, and stakeholder management. Other than PMBOK, this is not only model that used for project management. Later on in your studies, you will learn about other project management in other units, which are more agile models. Alright, so there are different type of project. There's like agile project, iterative project, or hybrid project. The 10 PMBOK knowledge areas just now are useful for larger predictive project. Let me just get my pen. Predictive project. Alright, so different from agile project. Agile project management means the project always keep changing based on the current situation, while the PMBOK is more useful for a waterfall style of projects, such as the one that have specific scope and goal. Alright, other than the waterfall projecting, agile project management is also desired in IT fields. Alright, so later on in other the other subject, you will also learn about agile project management. Next, we have Covey's quadrant for time management. Okay, using this model, this is the model, time management model, we can categorize our work into different importance and urgency. We will need to do something important and urgent first before doing something important but not urgent. For example, fixing security bugs with users' data will be important and urgent matter than, for example, just promoting sales on the product that you have on your website. Alright, so you need to know which one is important, which one is not important. Last week we have something called the first area, which is the project integration management, which involved to coordinate the other 8 of the PMBOK throughout the project lifetime. Alright, and then we also asked about what are the key stakeholders, and the one who may be affected don't need to be informed, will be affected and involved need to be informed, and so on. If you need some refreshment, you can go back to that. And what are key stakeholders? Basically, the stakeholders is like the key of the project. Previously, I said just now, this slide I said is key stakeholder. No, this is just stakeholders, and these are the about key stakeholders. Person who knows about the technical issues of the project, the economic and stuff of the project. Basically, for example, legal for stuff like something related to legal, something that know about legality of stuff such as your lawyer and so on. Organizational stuff such as your boss. Alright, those are your key stakeholders. Alright, have you seen this stuff before? This symbol of ISO logo, or logo that's similar to this ISO 9001. Alright, so what do you think it means? Alright, is it a guarantee of quality? No, it is not. But it is a certification that verifies that there is an recognized system in place to monitor the quality of the product. But it underscores how important quality is to many businesses, if they are willing to go through a fairly rigorous process to certify in ISO 9001. What is quality? Quality is delivering a product or project that meets or exceeds the customer's requirement and or expectation. One of difficulty of managing quality is like beauty, and quality is in the eye of the beholder. All right. For example, here like the one that the one that customer require, all right, either satisfy them or not. I mean, satisfy their requirement or not. All right. If it's exceed or satisfy their requirement, means that it will be quality product for them. But if it's not, then it's not a quality product for them. Which is why we need a continual improvement of the managing the quality management system of the product as well, to see the customers' feedback. All right. As what said by William Gates III, if General Motors had kept up with technology like computer industry has, we would be driving $25 cars that got 1,000 miles to the 1 gallon of gas or something, right? So basically it says like the car price will reduce because the technology always get more advanced and advanced, so it get cheaper or something like that. Okay, so the General Motors response, all right, to the statement of William Gates III, which is aka Bill Gates. That's Bill Gates actually, right? Okay, the response is, if General Motors had developed technology like Microsoft, we will all be driving cars with the following characteristics. For no reason at all, your car would crash twice a day. Your car get blue screen, who knows? Tesla probably gonna get blue screen one day. It's kind of scary. While turning left, your car would shut down and refuse to start, in which case you will need to reinstall the engine. Macintosh will make a car that was powered by the sun, reliable, 5 times as fast, twice as easy to drive, but will only run 5% of the road, meaning less software it runs, even though it runs a lot better. The airbag system would say, "Are you sure?" before it goes off, which is your, the account control thing. And every time General Motors introduce a new model of car, buyer will have to learn how to drive all over and over again. And finally, you will have to press the start button to shut off the engine. So basically, what we are saying here is like, you need to know what's your client's expectation. All right. Basically, like the quality is different in a way. This like two different view of quality, like faster, more what's called it, doesn't mean that it's cheaper, and then it's like faster, it doesn't mean that it's more quality in a way. Sometimes product need to be reliable to be quality, sometimes product need to be cheaper and faster or more like value to the money to be a quality product. So quality is kind of differs to the customers. So yeah, quality is in the eyes of the customer. All right. These Pareto charts help us to identify the critical issues in quality. Quality relies heavily on good communication with stakeholders at all levels. Stakeholders, which includes your customers as well. Okay. Differences between different type of quality in IT industry is like Netflix. The quality might be means that the data, the video get as fast as possible to the customer, even though you drop a few frames. But then something for like bank system, the quality means that it doesn't drop any data even though it take longer to process. Okay, like how would you feel if you sold your house for like $1 million, but in the end you only get 100,000 transferred to your bank account, right? Would you accept that by saying that the router drop or something in the middle of the data transfer, or right? Just to get your money faster, all right? That's why you need to know what kind of quality that you and your customer expect. If the quality is important, then you need to do test. All right, you need to test your software, you need to test your hardware, and so on. All right, there's different type of tests, which is unit test, integration test, system test, and user acceptance test. All right, user acceptance test is prior to client sign off. So basically, you ask the client to test the stuff as well, all right, to ensure that they are fine with it. All right, warning, the next few slides is rated PEGI 18. this is also included inside the Australian slide, so it's not just me. So I'm not trolling y'all here, but yes, it contains sexual references and occasional coarse language. It says here, dear rich bastard. The National Westminster Bank admitted last month that it keeps personal information about its customers, such as their political affiliation, on computers, but now Computer Weekly reveals that a financial institution, sadly unnamed, has gone one better and moved into the realm of personal abuse. Okay, the institution decided to mail 2,000 of its richest customer, inviting them to buy extra services. One of his computer programmers wrote a program to search through its database and select its customer automatically. He tested the program with an imaginary customer called Rich Bastard. Alright. Unfortunately, an error resulted in all 2,000 letters being addressed as Dear Rich Bastard. And the luckless programmer was subsequently fired. In New Scientist, 28 August of 1993. It's a really long story, long time ago story, isn't it? But yeah, so be careful when you do your program and you try to use weird names. I do that in the past as well, such as like bottles like Manko or something, you know, like just quite dangerous. There's also some kind of like quality assurance that you need to do. For example, in this picture, all right, what this picture says is supposed to be saying kanting, which means like the restaurant, dining place in Chinese, but then like because of the developer or like the person who translate this to English doesn't understand the English word, so he translate the fan yi fu wu qi chuo wu become translate server error, which is what you get when you try to translate something but the server is not responding to you. So yeah, this is what happened for real. Next one is about this word, this character called gun. So it can be dry or doing something. All right, gun. So the do have different meaning. All right, for example, did not me. I didn't do this and I didn't put this slide in. I'm sorry. Oh, don't cancel me, please. All right, next we have ganho, which means either dry items or sorry children, which resulted in the supermarket somewhere in this earth to have that ganho inside a sign and translate in English to something that you don't wanna say. Probably spread the F in the fruit. Effing good and effing, you know, effing goods. All right, so that's why quality assurance is important when you do your IT stuff or other design stuff as well, in, you know, referring to this. Okay, next area is the sixth area of PMBOK, which is project human resource management. Okay, understanding human psychology is an important ability when recruiting people in your businesses or project team. For example, what kind of skills are required to get to the project completed? What skill you need to get the project completed? Okay, for example, you don't recruit someone who expert in Java programming language to do project that do JavaScript. Java and JavaScript is different things. Okay. Next is how do we procure those who have skills, or how do we train people to have those skills, and so on. Okay, that's what we need to do in the project resource management and PMBOK area 6. Next we have area 7, which is project communication management. Alright, so when managing communication, the following decision need to be made. Who is responsible for the communication? To whom do they communicate to? What do they communicate? Is it about the progress, about the changes in the project, about downtime of the current system, how they will be communicate, okay, when they will communicate these things. For example, okay, for me, like I'm the one who responsible for the communication. and then to whom do I communicate to, which is my student, and then what do I communicate about, like class, the Hyper-V progress probably, changes in class, and like yeah, what happened to the Hyper-V, remember about that thing, that's the communication going on. How they will communicate, how do I communicate to you, I use Discord, and then like I also use email and so on. Alright, when will I communicate these things? Whenever I'm awake, apparently. Okay, next we have the area 8 of project management, which is risk management. Okay, before we can manage a project, we need to ascertain that the impact, the evaluation of this risk will have on this project. Alright, the likelihood of the risk to happen and how to mitigate the risk. So basically, how much it will affect the project, how much chance that it will happen, and how to avoid it from happening. Since we cannot actually just like what's it called again, mitigate everything, we cannot really like predict everything, we cannot really like making everything perfect, so we have some kind of technique to use for risk mitigation. For example, we have quantitative technique, which is based on expected monetary value. Like, okay, we have the chance of the thing happening and how much of the how much of the money will need to be spent if that risk is happening, and then like we use this P times the outcome here equal to the expected monetary value of the risk. Okay, for example, here we have like 20% of it happening, maybe like because of fire in the building, and then it will cost us $300,000. So basically, like our expected monetary value of that risk when it happened is $60,000. So we can spend maybe like half of this to mitigate the risk. Who knows? Like depend on your strategy in your business. And also, how about this one in project one? Also, 80% of it to happen, maybe that will cost 40,000 ringgit. Probably scope change. All right, scope change. Your client don't like your project and everything, okay? So they ask to change the scope, and then you need to spend that much money to maybe hire people, get more people to do your project, need more time, need more resources and all that. And then like you can time this, right? These two together and expected monetary value of this that will you can use to evaluate how to mitigate the risk, okay? Next, we have qualitative technique, which is probability impact metric. I prefer to use qualitative technique, as these techniques are better suited for having guesses as input. However, it is difficult to combine risk to allow us to identify risky stages of this project. Okay, something like this. Let me see. First priority over here. What happens? Something like maybe fire. Not fire. The scope changes. Maybe the people who in my team cannot do the project is over here. All right. Maybe fire. Maybe over here. And the low risk probably something like let's see. Low risk. My printer not working. Actually, that's quite high risk when you think about it, isn't it? But you have these two techniques to strategize your risk management. Next area, we have the area number 9, project procurement management, which is to ensure your procurement practices align with your client's practices. Make procurement decision in the right order. For example, business practices determine software requirement. Software requirements determine the hardware platform, operating system, hardware specification, and training requirement and HR requirement. Okay, for example, this company, this is Apple company, and then they want to make a program, and then you suddenly make them Android program. Cannot like that, okay? And especially if their hardware is just for the Apple program, and then their people, their trainees I mean, they are HR people, the employee. Yeah, employees. Yes, that's the word. The employee all use Apple product, and then you suddenly make them the Android platform system. Cannot do like that, because it's also their business practices to use their own system. So make sure that you get approval before you spend the client's money. Procurement management also deals with the contract. It's also included inside the area number 9. So what is the standard operating environment thing? Standard operating environment, which is SOE. Okay, it means that you restrict hardware purchase to pre-approved model. Maybe that company only use Dell, maybe that company only use Acer, who knows. You restrict the number of model approved to a number of category. For example, standard workstation, power user workstation, and server. Maybe that company only use Linux server. You cannot buy them Windows server for some reason. Okay, like not for some reason. I mean, what am I saying? Basically, like, you cannot buy them Windows server because the system will not work on the Windows server if the company that you try to do only use the Linux server. Okay. Okay, these tend to be all from the same vendor, thus increasing the compatibility between the computer, allowing cloning of these images. So if you use something like from the same vendor, it's gonna be easier for you. For example, if you have like some computer with RGBs, you know that it's quite difficult for you to control the RGB color thing. If you have product from different vendors, like, you need to have different program to change the color for your PC's item. Okay, so basically, if you use one vendor, it's easier for you to control, and it's more like have less problem with each other. All right, let's get down to business. It's gonna get difficult. Okay, do you still remember your OSI model layer over here, which have a 7, starting from physical layer, data link, network, transport, session, presentation, and application? Today we're going to learn, and I will explain to you about TCP Ip Protocol suite, which is Tcp Ip Model, or we also call it the DARPA layer. Tcp Ip Protocol suites are developed by DARPA in the 70s. DARPA, which also called Defense Advanced Research Project Agency, which is a part of United States Department of Defense. It is built based on the OSI model. Instead of having 7 layers, it has 4 layers. These layers, which are network interface layers, alright, which consisted of the media connection and frame relay. Next, we have the internet layer, which consisted of the IPv4 and IPv6 protocols. And then we have the transport layer. In transport layer is where TCP and UDP protocol existed. As you can see from the way that people drink in the picture, right? Yeah, they drink water in that picture. It explains how TCP and UDP works. TCP carefully pass the water, while UDP just empty the water bottle as fast as possible, and does not matter if the water got inside his mouth or not. Basically, TCP is like, you make sure each of the water, get inside the mouth, and before you drinking more water, while UDP just like as much water as you can in as fast as possible time frame. All right. While in application layer, there are some of the protocol exists over here, the HTTP, FTP, SMTP, and so on. So in this protocol layer, the application layer, we have something called socket. Okay, so are you familiar with any of this protocol? HTTP, FTP, SMTP, DNS, RIP, and SNMP. For example, HTTP is a transport protocol that uses the TCP port 80. This combination of the protocol and the port are called socket. Okay, So do remember the rest of the protocol as well, because this kind of question usually appears in exam. Okay, so do you know any other protocols? For example, something for Microsoft SQL Server, which is TCP socket of TCP port of 1433, remote procedure call RPC, which is TCP or UDP 135, and so on. Okay, so before we move on, I'm gonna like do some kind of like refreshment. What are the minimum address IP address component for communicating with other devices on a LAN? Okay, on a LAN. Let me change my pen for a bit. Alright. A LAN, you need to remember you have a computer, a switch, and a computer. Basically, to communicate in the same network, this is the same network, you need connection between the PC, either using wired or wireless connection. At minimum, you need to assign IP address. Alright. But that IP address must be within the same subnet for them to communicate. Same subnet, IP address, connection between the two computers. That's what you need for minimum in a local area network. So what are the minimum IP address component for communicating with other devices on different LAN and different subnet, meaning different network? For question 2, it asks how to communicate to device outside of your subnet, which means external network, different subnet, wide area network, and so on, right? Other than your own subnet. So we need a router for the LAN to communicate outside of the network. Okay, you have your computer just now, switch, your computer, maybe more of your computer, and then a router, okay, before going to different network. Alright, so we need a router for the LAN to communicate outside the network. You need to assign default gateway so that the LAN knows where is the endpoint of the network, so it can go to different network. What is default gateway? So what is default gateway? Alright, endpoint of your network, which is this. Alright, your router, you know, you have a router that have like different Ethernet port at the back over there. Okay, this is the port that connect to your PC, for example, your PC. And then this port have address, which is address of your router. This is the endpoint of your router before going out. So for example, the endpoint of this one is 192.168.1.1 probably. Okay, you set this IP address as your default gateway inside your PC, so it knows that the 192.168.1.1 is the endpoint of the network before it goes out to the outside of your network. Okay, so the default gateway address will be your router address. So you need to remember that devices must be in the same subnet to communicate in the same LAN. Alright, thus an IP address and a subnet mask must be configured as at a minimum. So the IP address in the same LAN must be in the same subnet. So make sure that the subnet mask is also correct before it can communicate with each other. And in order to communicate with other subnet, a router must be used. A router is a device, or sometimes a virtual device as well. Thus, a default gateway address must be configured in order to communicate outside of the local LAN. Alright, default gateway usually is the router IP address. Default gateway meaning the last endpoint of the local area network, which is usually your router address, IP address of your router. Okay, as you can see over here, we have two subnet. How do you know it is two subnet? Okay, you see the subnet number, subnet mask. Somehow it's called SN over here. I call it subnet mask. Some people call it subnet number. Alright, we have 255.255.255.0. The 0 is the host portion, while the red color is the network portion. Alright, same as this one as well. You can also calculate it by looking whether the, how to say, 255.255.255.0 and 172.16.3.0 and 172.16.3.4.0 is in the same network or not by using the ending method. You can also do that. Like, remember, like last week I teach you how to do the ending method. If you do the ending method, for example, you do ending method on this part, the .3.11, and also ending method to the .4.21, you will get two different network over here. Alright, the .3.11 is this one, and this one, .4.0 is that one. So basically, if you get two different number after you do the ending method, that two network that you're trying to compare is in different network. Okay, so this one have two subnet. Alright, two subnet. And then the red color is the network portion of addresses unique throughout the network. Is different in different network. Alright, look at this. Yeah, you do the ending method to see if you want to compare as well. And then the blue one is the host portion. So to communicate, it needs a router over here. This is a router. If you see it's like round with multiple arrows, usually a router. Okay, so this one have the default gateway set on the router over here, which is .1. Also this one default gateway, you must set it. So this computer, this tree computer knows that it need to go here to go to the different network. Okay, so it's like this one also the same. The default gateway is the endpoint of their part of the router. Okay, this is one part of the network, and this is one part of the network. The subnet 1, the subnet 2. Okay, let me change back my color to red. In earlier days, you could only purchase three type of IPv4 network addresses, which are the Class A, Class B, and Class C. Class A had 8 network bits. 8 network bits over here. In other words, you could purchase one of the 256 network. Why 256 network? Because you have 8 network bits. 2 power of 8 equal to 256. Each of the network have nearly 17 million IP addresses. Why 17 million? Because we have how many? Oops, 24. Around 16,770,216 addresses for each of the network. Each of the 256 network. That's Class A. Last time, HP, Apple, and TNT, and Ford, the car company thing, all purchased a Class A address. You know last time, right? Like US Army had like 14 of that Class A network. It doesn't sound impressive in a way, but it is actually impressive if you hold 14 of the whole world Class A network when there's only 256 in total, the whole world. Alright, for Class A. Class B network had 16 network bits. Over here, 16 network bits and 16 host bits. 16 host bits. You could purchase one of over 65,000 networks and have over 65,000 addresses. Swinburne actually got one Class B network. In a Class C network, we have 24 network bits and only 8 host bits. There were millions of network addresses, but each only offered 256 addresses. There's a lot of network addresses you can get from Class C network, but in each of the network, you can support only 256 devices, not calculating the broadcast address, the network address, and also the router address. Yeah. So now we no longer use the classful addressing. We don't use this thing anymore because we don't have it anymore. Like, we ran of it ages ago. So now we just use something called the CIDR, which is a classless something. You can Google the full name lah. Right before we move on, you need to remember about the logical address constraint. For example, these are the addresses for loopback addresses where your computer just talk to themselves because they are lonely sometimes, and these addresses are reserved for universal broadcast addresses, which you cannot use as well. First address and last address of each subnet. That one you need to remember. First and last, which is usually the .0 and .255. You cannot use that, because that is your subnet ID, your network ID, your network address, something like that. You cannot use that. That is the one that define your network. And the .255 is the broadcast address of your network. Instead of universal broadcast address for all network, you have your own broadcast address, which is usually the .255 or the last address in the subnet. Okay, I will explain further what is the first and the last address. You need to remember this. This is very important. And then private IP addresses. You just cannot use these IP addresses for internet traffic, but then these IP addresses can also be subnetted, so you don't have to worry about that. If you want a server to host a resource, for example, your Minecraft stuff, right, from anywhere on the internet, just like what I did last week, you must allocate the server with a public IP address. Alright, for example, for us, we have our own IP addresses, which are dynamic IP addresses, unless you pay for one IP addresses set for yourself, and then you get the IP addresses that is your public IP address. You can use that address to access your computer from different part of the world, not the 192.168.0.1. Okay. Okay, the first thing that you already know about, which is a single subnet network. For example, we have here 198.64.32.0/24. 198.64.32.0/24. Alright, that is your network ID. That is your subnet ID. That is your network address. Same thing. Okay? Every device in a single subnet network share the same network address, which is the 198.64.32.0/24 in this diagram. As you can see over here, all these devices have this part of the network address the same, because they are in the same local area network, in the same subnet, in the same network. How do you determine which part of the network address is the network bit or the host bit? Which is to compare it with the subnet mask. /24 subnet mask is 255.255.0. Okay, 255.255.255.0 in binary it is 11111 over here, 111 111.0000000. If you see, after you translate the /24 or /16 slash something, the subnet mask translate to binary, the part where it is 1, it is equal to your host bit of your current network. You compare it to your network address compared to the subnet mask. If that's 1, this is the network part of your subnet, of your network ID. And the one that have zeros is the host part. So in single subnet network, every device has a unique host address. Okay, it applies to everything. Applies to every network. They have unique host address. Okay. Now you have the 198.64.32.0/24. You're trying to subnet this into 4 different networks. This 198.64.32.0/24. You're trying to divide that network to 4 different network. Not 1 anymore, but 4. It's called multiple subnet network. So how many bits do we need to represent the 4, the number 4? How many host bit we need to borrow from the network, how many network bits we need to borrow, subnet bits we need to borrow from the host bit? We need to borrow 2. Why we need to borrow 2? Because we have 2 power of 2 equal to, wait, no. Mathematics. No. What am I doing? 4. There you go. So we need to borrow 2 bits. We have to borrow 2 bits. Remember just now, our subnet mask is equal to /24, which is 1111 1111 1111 1111 1111 1111 0000000. Okay, this is our subnet bit just now. Now we need to borrow 2. So we need to borrow 2 of this, okay? We need to borrow 2 to get 4 network, because 2 power of 2 equal to 4. And then that is when our subnet mask becomes /26. Because why? Now instead of .0.0 at the end of here, we just borrow 2. So we have another .1.1 here. .1.1 of the /24. /24, we borrow 2 bits. Now we have /26. So our network mask, new network mask after subnetting, is now /26. Alright. So our subnet mask becomes /26. So and then you think, why is this 64 and why is this 128? Because we have how many bits over here? 1, 2, 3, 4, 5, 6. 2 power of 6 equal to 64. So you have 2 power of 6 equal to 64. So your network hop is the word you need to remember. Network hop is the one you need to remember. Now it is 64. Meaning every 64 of this number added to your network, it will become new network. Okay, now you see over here we have 168.64.32.0/24, correct? This is your network. 6432, that is your network. If 6433 is not your network anymore, your network only 64.32, not .33. You see, if you borrow 2 bits, which is 4 network in total, you get subnet of 198.64.32.0/26. That's your first. 198.64.32.64. That's your second subnet, second network. 198.64.32.128. That's your third. You see, you keep adding 64, correct? And then 198.64.32.192. That is your fourth network. And then you ask, what if we add another 64 inside the number over here? Alright, if you add another 64, the address will become 198.64.32.256, which does not exist. You need to remember it maximized at 255 and not 256. So if it's already 256, meaning that the legit number after you add another 64, the IP address will become 198.64.33.0, which is not your network anymore. Okay? You will need to practice this again and again, but I will explain more stuff, alright? Okay, you need to remember that there is a cost when you're doing subnetting. Every time we borrow a bit, the number of potential subnets doubles, but the number of hosts in each of the subnet half. So every subnet, we create new subnet ID and a new broadcast address. So we lose another 2 address for each subnet created. Okay, when you have one subnet, 192.168.1.0, you cannot use this address, and then also you cannot use this address, 68.1.255, because that is your broadcast address, so you cannot use that address as well. You already lose 2 host address, okay? What if we do something like just now? We make a /26 and borrow, get 4 subnet. Right, let me see. 4 subnet. 192.168.1.0. Next one is 192.168.1.64. 192.168.1.128. 168.1.192. Okay, again, for 4 subnet, we have 192.168.1.0, 192.168.1.64, 192.168.1.128, and 192.168.1.192 for subnet. So this address cannot be used for host, and then also the address before this, alright, which is the .63. Right, this subnet, they have the .63, aka the 192.168.1.63, cannot be used as host address as well, because this is a broadcast address for the 192.168.1.0 subnet address. And then for the next address, also the same, 192.168.1.127 cannot be used in this network address, because it is that network address broadcast address, and this one 191 and this one 255 cannot use in that network address because they are the broadcast address. So I have a question for you. The answer will be inside your Canvas slides. How many bits we need to borrow if we want 8 subnets? Just now we want 4 subnet, we need to borrow 2 bits. Now we want 8 subnet, how many bits we need to borrow? How many bits do we need to borrow if each of our subnet must have 8 addresses? In this case, it includes the ID and the broadcast address. Alright, for the number 8. 8 address includes the broadcast ID and the network address. In each of that, for the addresses, for the question 2 address, try to borrow as much as possible before you and maximize it until you only get 8 addresses in total. Okay. So why do we use subnetting? So we can use that single network address that you receive across multiple locations. For example, in the previous slide just now. Alright, this is the 4 subnet that we created. Okay, maybe this one is for Sydney, Melbourne, and so on. But then, like, for easier understanding, I can say that maybe your house have the 192.164.32.0 just now. And then you have 3 siblings and 1 set of parents. Okay? So each of your siblings live in different room. And your parent also live in different room. So you can separate the network. Your room, your own network. Your parent room, their own network. Your brother room is his own network. Your sister room is her own network. So basically, we just separate those networks so we can have something like security reason. Okay, listen. Alright. Everyone have things that they want to hide, so their sibling cannot access from the network access. You know that some computer actually share the stuff in your network. You can go to your network tab in your Windows Explorer. You double click, you can see someone else PC over there. You can access some of the data in that network actually if they accidentally enable it. If those stuff in different network, it cannot be accessed unless it is configured to have a router to communicate between of those network. Alright. Also, different network will have different less congestion when you play game or something, right? This network different stuff like router that process it. This network different router and different switch that process it, and so on. Other than the multiple location, you can just separate the network to reduce congestion and to increase the security by giving access, set up firewall for the for each of the network to access each other. In a bigger picture, okay, we have just now like Swinburne have class B, correct? Class B network. There may be subnet it more than this, but for example, there's Australia subnet and Sarawak subnet. If they don't subnet the network, separate the one that class B just now into 2 network, whatever traffic between Sarawak and Australian network will be processed together, so that will congest the network traffic. And also, like we can access each other data freely, which also increase the security risk. So by separating this, we can set firewall in between to say like which data, which port can be accessed, and so on. That is why we have subnets. Okay, next we have more exercise. You can do this. The answer is over there. Like either you do networking previously or not. You can try to figure this out. Okay. All right. Now back to the calculating of IP addresses. Remember when we do the ending method last week? All right. Now we have address of 172, IP address of 172.16.255.1, and then the address subnet mask of 255.255.0.0. We change the address into binary, and then we change the mask to binary, and then we do the ending method. That ending method will result in your network address, your subnet address, your subnet ID, or whatever you want to call it. Okay, So just now the address that you receive 172.16.255.1 is an IP address. It's a host IP address. It is not a network address. So you need to do the ending method to find the network address, which is this. This is the network address. Alright. To find the host portion, alright, all 0, alright, to find the subnet ID, the network address, whatever, you make the host portion over here, host portion, you turn this to all 0, this up here to all 0 to find the host portion, which is your network address, alright, after you do the ending method also can, this one also can. And to find the broadcast address, which is the address that the network address used to communicate with all the hosts inside the network address, change it to 1. Change this to 1, so we can get the 255.255 at the end. 172.16.255.255 is your broadcast address. These two addresses cannot be used in a host. Okay? Next is a technique called subnetting in a flash for non-255 mask. If you receive a non-255 mask, maybe /26, /27, /28, /17 or something, alright, it's like not ending in 255 in the end, you can do this. Okay. You subtract the non-255 with 256. For example, in a 224 subnet mask, if the ending is 224, so you subnet 25, you subtract is a word. You subtract 256 to 224 and then you get 32. This is your what again? Network hop. So it hop by 32. So your subnet goes by .0, .32, .64, .96, .128, .160 and so on. Okay? What if it happened like this? 255.255.224.0. It ends at the third octet. Same thing, 256 minus 224 equal to 32. The network hop is 32. But the subnet mask show that it is at the third octet. How does it go? So it goes like this: 192.168.0.0, 192.168.32.0, 192.168.64.0. It happens in the third octet. That's another technique that you can do to do subnetting. Okay, just now the 192.168.10.0, and then we have the .224 in the end, right? We have 32 network hop. This is each of your network. Your subnet number 0, your subnet number 1, subnet number 2, subnet number 3, until subnet number 7. Alright, your network ID 192.168.10.0, your first usable host address, the one that you can assign to router, computer, phone, and so on, is 192.168.10.1. The last one that you can use is 192.168.10.30. The broadcast address, which is the address that the network address used to communicate with all the device in the network, is 192.168.10.31. The next network, alright, the subnet number 1 over here, instead of subnet number 0, remember we count from 0 sometimes. Subnet number 1, 192.168.10.32. Alright, after the broadcast address. This is the network ID for the subnet number 1. First address can be used is the .33, and the last one is .62. And the broadcast address is the .64. .64 is the broadcast address, and so on. More question over here. You can answer. I mean, you can check it later on. What if we receive 172.16.0.0/18? /18 is, okay, you can count like this if you want lah. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 255, right? 1, 2, 3, 4, 5, 6, 7, 8. That's 16 already, right? 255.255. 16, right? 16 of it. 17, 18. So you need 2. 1, 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And then the rest is 0. Okay, so remember how to calculate the binary thing? Over here, this octet, alright, this octet is 128 plus 64 equal to 192. So we have the number /18 equal to 255.255.192.0. So subnetting in a flash, 256 minus 192, we get 64. So the first subnet 0, the first subnet that we have is 172.16.0.0. Because our hope is 64. The subnet number 1 is 172.16.64.0. Why is it over here? Because the non.0 is happening in the third octet, not the fourth octet, okay? So another subnet is 172.16.128.0 and so on. Okay? Woo! And this is how you configure IP address manually, which already shown in your lab. You can check your lab. Hopefully you all can do your lab for now. Not sure as well. And then this is how stuff that you can use to troubleshoot your IP addresses. You can check one by one to make sure that your configuration is correct and ready to go. And you can use tracer to trace your network router thing, which route they take. And then when you troubleshoot the stuff, you troubleshoot from bottom up to above, meaning that, okay, you check a wire, you check your Wi-Fi connection and so on, and then you check your IP addresses, and then you check your DNS addresses, your default gateway addresses, and then you check the other thing afterward. Whew, I hope you all understand that. Next week lecture gonna be more in depth on IP subnetting. Try your best to understand the IP subnetting for this week first before you try to move on the next week, because next week is a bit more complicated. But then that's about it for this week. Thank you for viewing the lecture. I'm too lazy to do an outro because I've been speaking for the past 2 hours plus. Any idea what intro to do next week? Or should I still do my VTuber stuff? Remember to do your lab if it's available. Do your lab 1 first, and then lab 3. Lab 2 you can think about it later on. It is quite important for exam a little bit, but not for your skill exam. It's only available for your other 3 exam. So your Hyper-V stuff is more important. Okay, so that's about it. Thank you for viewing the lecture. Sayonara. Goodbye. Ichi-ni-san, arigato.